15 years. Presently, I'm working in SL. And also, I have been associated with other volunteer organization as well. Without any further delay, I'd like to start the session. In the first session, we got more insight on the standardization and on different routing protocols, as well as more insights on security. We had a fruitful sessions, and we, as a technical resource, we got more updated on these sessions. Usually, every year, NPNOG is hosting this conference and workshop sessions, which helps everyone, especially on the technical front. We used to get updated, as well as enabling the youth generations on the technical space. NPNOG is started in 2016. Within short span of time, we had NPNOG conducted successful events, and we aim to continue this in coming years. In the post session, the first technical operation, I'm going to moderate. On this session, we have three dedicated speakers. The first one is by Anurag Bhatia. The second one by Ramkrishna Dahal, Sitaram Khatka. And the third one is by Kiran Devakota from Whirling. Without any further delay, I would like to invite on the stage Mr. Anurag Bhatia for giving a session on automate on internet transfers and routing configurations. Thank you.
I have the clicker.
Excuse. You have just 20 minutes, allocated 20 minutes. Within that time, I request you to complete. Thank you.
This one will be. Right. Good afternoon, everyone. My name is Anurag Bhatia, and I work at Hurricane Electric. So I'll be talking about automating your internet exchange route server config. Before I jump into the slides, I'll give a quick introduction about Hurricane Electric as well as the Bharat IX, the other name you see in the slides. So we are a global operator right now, operating in around 41 countries. So we are a wholesale transit provider, and we have around 170 POPs and present in almost 180 exchanges at this point of time. So a large part of the content as well as the experience for the slides come from a large number of BGP sessions we have and a large number of BGP route leak related issues we see. Over the time, we have added as many as 21,000 BGP sessions in our backbone, and we are right now paired with over 7,000 individual networks across the world. So while we were working on that, we realized over time that it's important to participate on the route servers, and it's hard for a larger network to participate at the route server. We follow open peering policy. We are happy to pair with various networks present in the exchanges, but it's hard to participate on the route server because of the filtering as well as the route leaks related problems. While alongside, I got involved in volunteering for an internet exchange in India, which is called Bharat IX in Mumbai. And as we were setting up the exchange in Mumbai, we realized challenges around automatically generating the configuration to support certain features. So that's the brief background about these slides. So I'll talk about how we set up the exchange and the tools we are using for config management. So how would you manage route server config in 2018? Of course, at this point of time, as Mr. Sailesh was giving introduction about Tata, you don't expect people to put conft and go into the config and make changes. So you expect certain automatic mechanisms. Quick introduction about peering on the internet exchanges. For people who might not be familiar, you have option of bilateral peering as well as multilateral peering. So you may be present at an exchange like NPIX, very good exchange. I just visited yesterday, by the way. You may be peering with other members bilaterally over the exchange. It could be over shared peering fabric. And then you can also have the option of multilateral peering, where you peer via a route server. Various large exchanges in the world do run route servers, and that helps to solve the peering problems in terms of having lesser number of sessions. If you check out some of the largest European exchanges right now, they have over 600, 700 peers. So for a network to go and participate there, it's very hard in the absence of route server. They cannot simply go and have BGP sessions with all those existing players. So that's where the route servers do play a very important role. So what a route server does, it just shares the routes without modifying the next hop, as most of the engineers here would know. You are not supposed to put next hop self. If you do that in an exchange, you're going to cause a big fat outage. It exchanges the route, the actual traffic flow stays the same. So it's important to see if in a mechanism like this, whether you have bilateral peering over IX or whether you have multilateral peering, the actual traffic flow is exactly the same. It's just the mechanism of exchanging routes. Actual flow does not happen via route server. It is often desired that exchanges run transparently. They do not inject their ASN. Some of the largest exchanges, actually almost all the largest exchanges in the world do that. They do not inject their ASN. There are certain exceptions. For example, Hong Kong Internet Exchange in Hong Kong, AS4635, that does adds its ASN in the AS path. And another exception comes from India. So in India, NIXI does add its AS number 24049 when exchanging the routes. The reason why it is desired that route server does not inject its ASN is to make sure that you are not unnecessarily increasing the AS path length. Again, I'll go back to the first slide. This is important because bilateral and multilateral, the flow is supposed to be the same. If you inject the ASN, it is going to make the route less preferred, and hence it makes no sense to have that in place. Plus, the traffic is not flowing from route server, so why would you do that? Third feature, which is often desired, and we actually wanted to do it from day one when we were setting up the exchange, it's that route server does route filtering. Why route filtering is important, we already heard from Krishna in the morning session on mutually agreed norms for routing security, manners. In order to do route filtering, it seems very simple and very easy as long as you have certain downstreams. If you have one downstream, you can just create ACL. You filter them manually and you are done. The problem comes if you have larger operator participating in your exchange. And at that point of time, those operators have downstreams, which further have downstreams. How would you know that a network downstream to your downstream has added certain prefixes? How would you filter them? How would you add it in your process? That becomes the tedious task. So route filtering, while it seems very, very easy and very important based on the available options in devices, it's extremely hard and close to impossible once you go beyond the edge case scenario. And we see that all the time in case of Hurricane Electric, where we are the transit provider to some of the regional networks, and it becomes very tedious to filter them. The fourth feature, and this is again, it's a desired feature, but this was the feature which actually triggered us to have the system. It's that route server should offer a BGP community support to the members so that members can control their routing. When we set up the IX, we just started with a couple of route servers. The first part was that it was already so much delayed that we didn't want to spend too much time into the config part, so we just started up. We got a couple of peers, we created BGP session by hand and just got it running. Next, we had a content player who wanted to come and wanted to have the BGP community support. They wanted a support where they can tag their routes with the community and make sure that routes do not go to certain peers. This is an important feature with some of the large content networks want these days, because they want to control the route flow. And if you do not offer them this feature, if you're running an exchange and you do not offer this feature, they're not going to join the route server, or maybe they won't even join the exchange. So it becomes important, although it's still a desired feature. The reason why some of the content player want that is, one, many of them run Anycast. So in case of Anycast, they want to typically restrict the route announcement. They do not want the route announcement to go beyond a scale. So let's say a large content player joining an exchange in Mumbai, they might not be interested in serving traffic outside India from that POP. They might be interested to serve Singapore out of Singapore POP, Mumbai out of Mumbai POP, and maybe all the East Asia out of Singapore POP instead of Mumbai POP. And hence, they would expect the option of tagging it with a BGP community to restrict the announcement. The other reason, of course, is that they want a scenario where they can control the announcement and stop it if they find congestion, because many of the content networks monitor the performance of circuits, and they want to redirect traffic from peering over to transit if they see a serious amount of packet loss. So the challenge. First one is, as I already mentioned, IRR-based route filtering. It is challenging. One, because a large number of networks do not have route objects. If you look at 700,000 odd routes in case of IPv4 routing table, a very large percentage, in double-digit percent number, does not have route objects. A very large percentage of routes have route objects, but the origin AS mismatches. Why that happens? Because either they have purchased other companies and merged them and did not bother to update it, or there are scenarios where they just use someone else's pool, not hijack, but on some kind of lease agreement. So a large number of those announcements are legitimate announcements, and if you try to build filters, it becomes tricky. If you are going to filter a large set of user base, and we are finding the same problem in case of our Hurricane Electric Transit network, where we try to filter and we see large number of legitimate routes being flagged as the illegitimate ones based on IRR. The other part about the BGP community support, it's challenging technically, because typically in Exchange route server, you had a policy where you would filter the inbound route, you would not filter the outbound route. So you would have a route map or an import policy on the routes you are receiving from peers, while you would have a common export policy on all the peers you are announcing the routes to. In case of BGP community support, that's not going to work. In case of BGP community, you want a scenario where if you have a tag, say 0:1, make sure you do not announce it to AS1. So you got to create a filter saying, in BGP session with AS1, if there is a tag 0:1, reject the route. Now you need the same support for AS2, same support for AS3. So clearly that is very unscalable if you try to generate it by hand. If you have 10 members, you would need 10 separate policy for each of them, and having the rules for all other 9s to reject them if they have that specific tag. That doesn't scale up. Solution, we went for a tool called A Route Server Project. The name does sounds funny, but it's an open source project. It's A Route Server without the space. And it takes care of route server config generation as well as of those two problems which I just mentioned. It's from it's maintained heavily by one of the engineers who is working at Cloudflare right now. And there is an active community support. It's there on GitHub, and there is quite active participation in the project. So how to use the A Route Server package? You just initialize the package. You add the peer details in client.yaml file. So it supports .yaml based syntax. You just add the peers in the YAML syntax, and then it takes care of generating of config as well as pushing it. The pushing has relatively vague support because it essentially generates a text file. But since it has an Ansible role, one can always have a system where you generate it and you can push it using Ansible to the actual route server. So here's an example. This is on Debian Ubuntu. So by the way, in our scenario, our route server is based on Ubuntu. So we use Ubuntu LTS releases. It's Ubuntu 18.04 right now. And essentially, we are running for the hypervisor, we are using Proxmox. So we have two servers. One is the Dell R410, relatively decent server, while the other one is simply an Intel NUC. You do not need really powerful devices to run route server. I can probably do that even on a Raspberry Pi these days. For a starting IX, all you would have would be maybe a few thousand routes. So even a Raspberry Pi can very well manage that for a while. So we have two physical devices, and then we run LXC containers on top of them, and then we generate the config and push it to them. So you need to have the support for Python as well as Python 3 dev. You need to have support of BGP Q3. That's very important tool, and you might have seen this name in Krishna's slide in the morning. BGP Q3 is the tool which speaks to IRR and gets the prefixes. ARoute server is the one which essentially interfaces with the prefixes and generates the config for the bird. And then you need to have support for Python pip and so on. I'm not going to go with the names of all the packages. You can see that in the slide. For installing the package, we just use pip. So it's a Python maintainer, and we just get it from there. And then you run the configure. Since we are running 2 route servers, it's important to have separate installation for each of them, while the client config is exactly the same, because we ask all the members to peer with both route servers for redundancy reasons. But things like router ID is different across both route servers, and there are certain other things which are still different. So we set up the server with this mechanism, while for clients.yaml we use Ansible to push it to the servers. So we don't have to do it twice for adding each peer. Here's an example for clients.yaml. It's extremely simple file, very easy to read, as the promise of YAML in most of the configs. So here you are defining the ASNs. This is an example showing AS22. It has AS set. You just define AS set, AS2 to main. If you do not define AS set, and that's one of the best features the package has, it's going to pull it from the peering DB. So as long as you're peering with anyone who has a valid, legitimate peering DB record, it will just pull the AS set from the peering DB. And then you can always define IP. In our case, we define IP as well as IPv6 in the package. And you have other options, including defining of things like prefix list. Although that's becoming rare, it's more popular to define AS sets instead of defining prefix list specifically for Exchange config generation. Here's an example of how you generate the config. You run the package, then you define which daemon you are using. In our case, both route servers are based on Bird. Initially, we were using Quagga and Bird, and the plan was to have the software redundancy. But since this package does not support Quagga, plus Quagga was actually quite outdated, so the only reason to hide it was just for software redundancy. We might move to FRR in near future once we have support of a route server with FRR. So it would be much better to have FRR as well as Bird running on both of the route server on separate hardware that's good enough for redundancy. To automate the config, of course, you can run a cron job, and in case of cron job, you just generate the new config. Instead of generating bird.conf, you generate with bird.new. You test it, and then you let the bird to configure it. When setting up cron job, one has to be careful that you are not breaking the bird if something is wrong in your YAML file, which can be a case. So with the case of cron job, at this point of time, we are generating filters for all the members every day at midnight. So right now we have 9 members in the exchange, a large number of content networks as well as some of the local Mumbai-based networks, and we are generating their filter config every night. Does it save us from manually configuring? Yes. Does it save from hassle of updating filters? Yes. But is that 100% accurate? Probably no, because still we can come across cases where our members or their downstreams add prefixes and they do not create valid route objects. All those route objects are going to be filtered out. So that's one of the concerns, and we are still trying to work around that. Probably industry has to work on cleaning up the IRR databases over time. That's the only way out, at least for the AS sets. Coming to the BGP community support. So as I said, it has out-of-box BGP community support, and unless you tweak it and disable certain things, it's just going to support the BGP community right away. I'm going to give you an example of the communities which we support right now. So we support the one of the most important one, which is do not announce to any client. So that's 0 : the AS number. This was the first thing which triggered this whole project, where a content player wanted that. We have the option of prepending the route. So a member might be interested in prepending route to certain other member if they happen to have a relation, or if they happen to have a scenario where they see that circuit is chalked. So a member A might see packet loss in the traffic coming from member B because member B's transport has an issue. They may add a BGP prepend just specifically to member B using the route server instead of doing it. So that's very helpful. The whole logic of this activity is to make sure that you can replicate all the features you get in a bilateral peering into multilateral peering, so that you don't have to manage sessions separately, but you have single session with route server and have all possible features. You have option, apart from prepending, you have options of adding no export, which you may want if you want to extremely localize the announcement. You also have option of adding the no advertise, keeping it just specifically to the router, or versus keeping specifically to the ASN instead of taking it out of the ASN. Some of the other key features which are worth mentioning, it has support for ROAs. Right now, we have not implemented RPKI, but we are exploring that. Whether we add or not, it's not going to make a huge difference, but we are exploring at this point of time. There's still extremely small amount of prefixes which are signed by, which have valid ROAs, which actually have ROAs at all, not even valid. So that's one part which is more like a chicken egg problem. You need more support overall to work on these projects. Other thing which is there is the graceful shutdown. That's there is one of the RFC, and a lot of vendors are implementing it at this point of time, which is to signal your BGP peers that you are doing a maintenance and you want to shut down the session. That helps in preventing black holing when running BGP at an exchange or between two members. It has support of peering DB to pull the AS set, which I just mentioned. It has support for integration with the IXP manager. And as I learned yesterday, NPIX is using IXP manager, which is very nice. In our case, we explored IXP manager multiple times over a period of a few months. And so far, we are not convinced that it makes sense. We found it has lots and lots of options. And if we are going to use 3 or 4% of the options provided by the package, it may not make sense to use it. It's a lot of options around mapping the device, a lot of options around where your rack is, where your cross connects are. For a small exchange, that's more like a overhead to do that. Plus, in terms of monitoring, it has integrated support. While we like to use other open source options, so we are heavily using LibreNMS right now, which is monitoring. Apart from traffic, it's monitoring the up and downs as well as of the members. We are also graphing the optical power values of all the peers, and we have thresholds set for the optical power of the members. So if there is a significant power loss, we just get an alert. And with the available transport options of alerting, we do get alert on our Slack channel, which is quite interesting and useful if you're used to working in a team environment with Slack and all integrated. It has support for full RX config generation based on peering DB record, and that's very, very useful feature for large exchanges. So what you can do is you can run the package. You can tell it that I already have an exchange. It will ask you to point it to a peering DB record of your exchange. So for instance, if you point it to the record of NPIX, it will check the peering DB record. It will list all the peers, their IP addresses, and it will just generate the route server config. So you can literally start using it right away without pushing much effort. You do not need to generate clients.yaml for all the peers. I think when I checked last, there were 33 or 40, around 30 to 40 members in NPIX. So you can generate config for all 30 to 40 just by pointing it to the peering DB record, as long as it's current and updated. It has a support for Ansible role, and we are using it at this point of time. We recently started using it. And one of the reasons for using it was to make sure that we update clients.yaml just by doing it once instead of going to both servers and doing it. And there are certain deployments where it is advised to run the a route server outside of your route server. So you run a provisioning server where you run the package, generate config, and then push it. It can also be done based on the Ansible setup. Although at this point of time, we run the package exactly on the same route server which is running the bird. Plus, it has support for Open BGPD if you want to use that. That can be useful for the software redundancy, which I was just mentioning. Quick references. So, a route server project, that's there on the GitHub, and you can go there, you can contribute to it. The documentation is there on ReadDocs. It's getting quite popular for GitHub projects these days to use ReadDocs.io to put entire documentation. There's the Ansible role, and there's the IXP manager. If you do not want to use a route server, you may if you have a much larger requirement, you very much might be interested in exploring the IXP manager. And this is the Bharat IX. So that's about it. Any questions? Yep. Thank you. Thank you.
Thank you, Anurag, for the wonderful presentation. We got more insight on routing objects and how we can automate with the open source tools. This will be more helpful and handy tool for us, and where we can automate at our end. Once again, thank you, Anurag. So the next presentation is on DNSSEC, record validation, a model to protect you from counterfeit DNS. I would like to invite Mr. Ramkrishna Dahal, Sitaram Khatka on the stage. You have 20 minutes for this presentation. The stage is yours.
Good afternoon. So DNSSEC, record validation, a model to protect you from counterfeit DNS. I am Ramkrishna Dahal, and my friend.
And me, Sitaram Khatka.
He will be joining me in the latter part of the presentation. Domain naming system. Probably we all are very familiar with the term. It's a phone book of the internet, and you can access information online like google.com, facebook.com, gadgetframe.com by using the domain name system. Web browsers interact through internet protocol addresses, and DNS translate domain names to the IP address so the browser can load the internet resources. How DNS works. So first of all, the client type the domain name on the browser, and then the domain name is sent to the DNS resolver. The DNS resolver forward that domain name to the root DNS and asks for the IP address for that particular domain name. But the root DNS says, I don't know which one is the IP address. What does it say? The IP address of this domain name can be found in the following TLDs. So it gives the address of the TLDs. Now the DNS resolver asks for the TLDs. So give me the IP address for this particular domain name. Again, that particular TLDs tells, I don't know the IP address, but I know who contains the IP address for that particular domain name. Again, the DNS resolver goes to the authoritative, and authoritative gives the IP address, and see, so it goes back to the client, and the client access through the web server and get the information or the web page that is requested. Now, what is the problem in this existing system of the DNS? See, normally the client asks for the corresponding IP address to the DNS resolver. For example, in this case, the client is trying to access the information from the examplebank.com. And the examplebank.com is sent to the DNS resolver. And the packet goes to the DNS resolver. So there is a DNS cache. And it gives the IP address, what it has. If it does not have, it asks to the root and give it back. So once the browser gets the IP address, it goes to that particular server and access the information that is examplebank.com. So the client can access the page what is reside inside that particular IP address. So it gets the information and puts all the credential and use the system. But in this system, there might be some miracle happens. That is, the DNS can be counterfeited. When the client type the examplebank.com, it send the domain name to the DNS resolver. What happens if it is counterfeited? That means the DNS is cloned, and the cloned DNS gives the new IP address, which is not the real IP address, and the client try to access the information from that cloned IP address, and it access the information from the malicious server. And the malicious server normally creates a fake page that the client wants to access. That means what happens now? The client does not know from where I'm accessing the page. It gives the credential. First of all, it accesses the credential, and then it does not have the credential itself, so it says the message, so not matched. So again, the client entered the username and password. At that time, the malicious server redirected the packet to the real server, and the client performed the activity. But in that particular time, what has happened? The miracle happened, because the malicious server get the every information, every credential that the example bank has. Now, what does it do? It does the, operation as it needed to do. So this is how the DNS can be counterfeited. So to protect this, we have DNSSEC. How does it help? So there is basically two parts in the DNSSEC. So in the DNSSEC, every domain is signed. And if the domain is signed, the DNS resolver keeps all the information, though it is cloned. And the cloned DNS give the IP address along with the hash value. And the client browser try to unlock the IP address by the private key that is shared through the root, which cannot be unlocked. That means, so the server cannot be accessed. This is how the DNSSEC works and protect you from the unauthorized access. So DNS relies, it's like the question answering. So which one is the particular IP address, and this one is the particular IP address. So DNS resolver works on such way. However, unsecure DNS responses can be furtherized, that can redirect the traffic, this time to the trusted services to the malicious server. So DNS validation provides a mechanism with which data stored in the DNS can be more and fully trusted. So why do we need DNSSEC? As I mentioned earlier, DNSSEC provide a mechanism. It's a two-way mechanism. Every domain name is signed at the time of creation. And normally it is signed with the private key, and the public key is shared with the root. And the sharing process in the hierarchical form, so that will be explained in the latter part of the DNS validation. So basically in this part, what I want to share with you is DNSSEC fixes the big chunk of the problem, like it provides the integrity of the data. It ensures the domain name and the corresponding IP address is not tempered in between, and the particular IP address has came from the actual or uncloned DNS resolver. So it ensures that particular thing. So DNS does not provide the confidentiality. So DNS renames a public, so it remains a public database, and it should be treated such. So we do not focus on the signing part because it is done by the all TLDs and roots and the authoritatives. Basically, so our part is to focus on the validation part, because most of our ISPs are not doing this. They are not enabling the validation, though it is signed, not due to the validation in the ISPs. So our clients are on risk. So we want to focus on this part. Some basic relating to the DNS. See, normally DNS resource record are kept in such a way. Basically, there are different types of record, like A record, quad A record, NS record, MS record. There are different types of record. And the example, let's say the record is kept in such a way. So is es.net 600 in this IP address. That means es.net and the time to live is 600, and this is A type data, and the IP address is given. So everything is kept in such way in the normal DNS record. But in case of DNSSEC, so it has two things. One is the DNS record, another one is the signature. That is that we say is RRSEC. So there is example. So here we have, this is a DNS record, and this is the RRSEC. So during the DNS query, both resource record and RRSEC is also delivered. So in case of normal DNS, such type of record are maintained. But in case of DNSSEC, so for every record there is signature. For every record, there is signature associated with it. That means it calculates the hash value, and that hash value is encrypted through the private key. So this is normally, it works as a digital signature. So I want to share with you what has happened in DNSSEC till date. In 2005, a standard published is a request for comment 4033, 34, and 35. And in 2008, July, so Kaminsky disclosed a DNS vulnerability. There might be a big problem if we continue to use such type of existing system. So it normally in this paper, it disclosed the vulnerability in the DNS with the poisoned DNS. And in 2010, root zone signed. That means dot is signed, and then all the LTDs started to sign. 2010 July 29 .edu TLD signed. In 2010 December .net signed. So till date, most of the TLDs and even the authoritative also signed their domain names. So in 2010 January, Internet Society launches Deploy 360 program to help and accelerate the DNSSEC deployment. This was launched to just to aware that we need to use the validation as well, and we need to sign the domain names. And in 2013, over 100 plus CCTLDs and TLDs has signed. So I want to share you the recent status of the DNSSEC validation in the world. So this is the current status. That means number of DNSSEC validation is being increased till that time, and suddenly in 2017, it is declined. This is the see the status. So even in this period of time, it is in decline. So next, I want to show the status where we are. This is the countrywide DNSSEC validation status. See, we are there even, so can you point there, please? So Nepal, China, Nepal. Only 6.62% validation. This is the duty of our ISPs, just to enable the DNSSEC validation. But see, so our neighbor, Bhutan, we can see 60% validation rate. So you can just turn on the validation, and that part will be explained by my colleague Sitaram Khadkar. Thank you.
Thank you, Ramkrishna sir. As you are concerning about DNS validation, this part, I'm going for this part to describe how DNSSEC validation can be enabled. Why do you need DNSSEC validation? DNSSEC validation, why do you need? As already explained by Ramkrishna sir. Yeah, all the zones, all the root records, zone records, and all authoritative records are nearly all are signed already. But that is the one half of the work has been done. But the better other half, that is the important half part from our side. We should enable DNSSEC validation so that such records are enjoyed in the internet, and clients become more secure with the DNS validation. Technically, I am speaking technically, different name servers like Bind, Unbound, Power DNS, etc. are already have already enabled DNSSEC in its default configuration. But we have not done a simple task. I will show that in later slides. But first of all, before we enable DNSSEC, we should make some of the cases sure about some of the cases, like we should enable TCP connection at port 53. Most of the in general case, UDP port is used for DNS record exchange, but in DNSSEC, TCP port 53 should be enabled. Likewise, IP frame and TCP segmentation. IP framing and TCP segmentation should be taken in account. Different firewalls may block these things, knowing that they may be the attack or they may be the unnecessary things. Likewise, inspection of large DNS packets should be done before enabling DNSSEC validation. And one more thing, network address translation. Network address translation may disable reassembling of TCP segments in the path. That should be taken into account before enabling DNSSEC. Now, let's see how DNSSEC validation work. This time we are going to see the domain for DNSSEC.nl.
Someone's looking for an answer to the question, what is the IP address of www.dnssec.nl? In response, the resolver is sent not only the IP address, but also the DNS key and the associated digital signatures.
DNS record and the associated key is delivered to the resolver.
It has received hasn't been tampered with in transit. The response is checked for authenticity and validity. The checks are performed by a validator, a piece of software running on the name server which receives and verifies the DNSSEC data. The validator asks for the duplicate public key held by the parent zone for www.dnssec.nl. In our example, the parent zone is managed by SIDN. The DS is looked up in the NL zone file and sent to the resolver. The validator checks whether the duplicate key and the public key from the zone file are the same. They are. The duplicate key and the public key from the zone file match the same private key. Next, the validator uses the public key to check whether the digital signatures are correct. They are. The validator also makes sure that the digital signature is still valid, whether the current date is between the start and end dates of the specified validity period. It is. Once all the checks on DNSSEC.nl are complete, the resolver follows the same procedure for the NL domain. The DNSSEC data for .nl are verified using the duplicate public key as obtained from the root zone. Finally, the DNSSEC data from the root is verified, enabling the validator to conclude that the DNS data has not been tampered with in transit.
In this way, authenticated data is delivered to the client. The major task here we see that is ISPs who are hosting public DNS, they should enable DNSSEC validation in their server. This task is not so very tough. This is very easy task. We can see that many of us may have already seen this very often. We just want to enable DNSSEC enable in the option part of the name.conf. This is example for bind DNS server, name.conf. Then put DNSSEC validation, yes. Then manage key directory should be defined and the anchor to the root name server. The anchor to the root name server should be defined like this. The digital signature of root name server should be put here. And all the magic as seen in the video is done by the resolver, by the DNS server. My recommendation here is, instead of putting yes in this, if we put yes, we should define the anchor like this in the manage keys. But if we define auto here, like this auto flag, then all the key rollover parts and the DNS RRSIC part of root is automatically done by the resolver. So I recommend all of the friends to do the auto part in the DNS server. This will be very easy for us. Here are some command lines. I would have to take laptop for that. Oh, okay, let's skip that part and go forward. And in this part, I was about to show you that how DNS D command use and different keys can be verified with DNSSEC validation. Now let's see what are we doing. There are many responsibilities for different ISPs to our clients, but what are we doing? Let's see. This is the list of public DNS in Nepal. Most of you have seen your DNS as well, I think. They are previous one. These are the different public DNS servers, as we can see, most of the DNS servers are not DNSSEC enabled. This one is only DNSSEC enabled. This is ewnet.com.np. Someone must be from there. Here. These all DNS servers are not DNSSEC enabled in validation part. Second one. Okay, and the same graph as Ramkrishna showed you, the graph for Nepal, not for Nepal, this is for South Asia. South Asia is very devastating. This is going downward and downward every time. Let's come together. Let's come together and enable DNSSEC validation our DNS server and make the world much more safer. Thank you.
Thank you, Ramkishan Dahal and Sitaram Khadka, for giving a good presentation and illustration on DNSSEC. We all know on the domain space of DNSSEC, and is one kind of key opener or eye opener for us. Compared to statistics of Bhutan, we are very much low. And I hope like we can rise within 2 to 3 years, and we can make it more better. Thank you once again for the wonderful presentation. So the next presentation is on rural wireless broadband experience in Karnali. I would like to invite Mr. Kiran Devukota, project manager. He's from WorldLink. Mr. Kiran Devukota. Yes. So you have 20 minutes. Okay, thank you.
Good afternoon, everybody. I am Kiran Devukota from WorldLink Communication. म आज तपाईहरुसँग चाहिँ कर्णाली रिजनमा अथवा चाहिँ हाम्रो चाहिँ रिमोट एरियामा चाहिँ ब्रोडब्यान्ड कनेक्सनको चाहिँ एक्सपिरियन्स शेयर मात्रै गर्न चाहन्छु। यसमा यो प्रोजेक्ट हामीले चाहिँ एनटीए नेपाल टेलिकम अथोरिटी को चाहिँ सब्सिडीमा चाहिँ हामीले चाहिँ कर्णाली रिजनमा गरेका थियौं गर्दै छौं। यसको लागि चाहिँ हामीलाई अपर्च्युनिटी दिनुभएकोमा नेपाल दूरसञ्चार प्राधिकरणलाई चाहिँ हामी धन्यवाद दिन चाहन्छु। फर्स्टमा म सुरु गर्न चाहन्छु। ओके, मैले भने जस्तै अघि भनिसकेँ, यो चाहिँ हाम्रो चाहिँ दूरसञ्चार प्राधिकरणबाट चाहिँ जुन आरटीडीएफ फन्ड भनेर चाहिँ 2% ग्रस एडजस्टेड रेभेन्यू चाहिँ सबै आईएसपी र टेलिकमबाट उठाउँछ। त्यो चाहिँ सर्भिस प्रोभाइडरहरूलाई चाहिँ ब्रोडब्यान्ड नेटवर्क बिल्ड गर्न र इन्टरनेट एक्सेस प्रोभाइड गर्नको लागि चाहिँ 75 जिल्लामा चाहिँ अघि हाम्रो डिगामर झा सरले भनेअनुसार 75 जिल्लामा चाहिँ उहाँहरूले चाहिँ सब्सिडी प्रोभाइड गर्नुभएको छ। त्यो मध्ये चाहिँ 8 वटा जिल्लामा चाहिँ कर्णाली प्रदेशको 8 वटा जिल्लामा चाहिँ हामीले चाहिँ काम गरिरहेका छौं। कर्णालीको विषयमा थोरै जानकारी लिन पाउँदाखेरि चाहिँ यो चाहिँ अहिलेको उसमा चाहिँ भाषिक र सांस्कृतिक रूपमा चाहिँ धेरै नै विकसित ठाउँ भए पनि अहिलेसम्म चाहिँ गरिब र पहुँच नपुगेको ठाउँको रूपमा हामी चाहिँ चिन्न चाहन्छौँ। यहाँ कतिजना चाहिँ कर्णाली जानु भएको छ? एउटा हात देखेँ मैले, दुईटा, तीनटा, चार, थोरै जना मात्रै जानु भएको छ। यो ठाउँमा चाहिँ हामीले चाहिँ इन्टरनेट को काम गरिरहेका छौँ र यसमा पपुलेसन पनि थोरै छ र ठुलो जोन छ, नेचुरल रिसोर्सेसहरू चाहिँ धेरै छ, नेसनल पार्कहरू छ। यसमा चाहिँ हाम्रो चाहिँ तालहरू पनि ठुल्ठुला छन्। यो चाहिँ फोटोबाट चाहिँ फोटोहरू हेरौँ। यो सोफोक सुन्डो लेक, कर्णाली रिभर, रारा लेक, भ्यालिज, इभन यो पनि अर्को भ्याली, त्यहाँको लाइफस्टाइल्स, माउन्टेन्स, भिलेजेस, यो एउटा सानो नमुना मात्रै हो। त्यहाँको ब्युटीको चाहिँ सानो नमुना मात्रै हो। यो कुराहरू कुनै प्रेजेन्टेसनमा 15 मिनटको 20 मिनटको प्रेजेन्टेसनमा बयान गरेर पनि सकिँदैन। मैले जस्ट तपाईँहरूलाई अलिकति सेयर मात्रै गर्न चाहेको छु। हामीले चाहिँ काम गरेको रिजन भनेको 8वटा जिल्लामा छ। रुकुम, रोल्पा, कालीकोट, जाजरकोट, मुगु, हुम्ला, डुम्ला र डोल्पामा चाहिँ हामीले चाहिँ काम गरिरहेका छौँ अहिले चाहिँ। यसमा चाहिँ हामीले चाहिँ स्कुलहरूमा, हेल्थ सेन्टर्स र पालिकाहरूमा चाहिँ इन्टरनेट दिनको लागि चाहिँ हामीले काम गरिरहेका छौँ। यो चाहिँ 1209वटा साइटहरू छ र 62वटा चाहिँ पालिकाहरू छ र मोर देन 600वटा भिलेजेसहरू गाउँमा चाहिँ हामीले चाहिँ इन्टरनेट पहुँचको लागि हामी काम गरिरहेका छौँ। यसलाई चाहिँ हामीले चाहिँ 2टा प्याकेजमा डिभाइड गरेका छौँ। एउटा प्याकेज ए, एउटा प्याकेज बी। प्याकेज ए चाहिँ कम्पेरिटिभली अलिकति डिफिकल्ट छ। यसमा मुगु, हुम्ला, डोल्पा, जुम्ला पर्छ। यसमा चाहिँ टोटल 445वटा साइटहरू छ र अर्को प्याकेज भनेको प्याकेज बी भनेर छ। यसमा चाहिँ कालीकोट, रुकुम, रोल्पा र जाजरकोट पर्छ। यसमा चाहिँ 764वटा साइट्सहरू छ। टोटल गरेर 209वटा साइटमा चाहिँ हामीले चाहिँ काम गरिरहेका छौँ। यसमा सरी, मैले एउटा सानो भिडियो बनाएको, भिडियो सेयर गर्न चाहन्छु। यो चाहिँ हामीले त्यहाँ जाँदाखेरिको यो गेटवे अफ कर्णाली भनौँ, जुम्ला जाने चाहिँ एउटा मात्रै बाटो। भिडियोमा अलिकति प्रतिबिम्ब मात्रै देखिन्छ। योभन्दा धेरै गाह्रो र योभन्दा धेरै रमाइलो ठाउँहरू पनि छ कर्णालीमा। र अर्को च्यालेन्जेस हामीले चाहिँ त्यो रोडको च्यालेन्जेस भइहाल्यो। अर्को च्यालेन्जेस भनेको चाहिँ हाम्रो चाहिँ यो चाहिँ तपाईँको यो पुरै हिल्ली रिजनमा छ र यसमा चाहिँ 4300 4000 मिटरभन्दा अथवा चाहिँ 4500 मिटर 5000मा पनि बस्तीहरू बसेको छ। यो चाहिँ स्प्रेडली पपुलेटेड छ। एउटा साइटको लागि हामीले चाहिँ केही नभए पनि कुनै ठाउँमा चाहिँ 2-3टा रिपिटर पनि बनाउनु परेको छ। यो तपाईँहरूले देख्न सक्नुहुन्छ, यो गुगल अर्थको चाहिँ प्लट लिएको छु। यसमा चाहिँ यो डोल्पा जिल्लाको हो, एउटा सानो हो। यस कुनै गाउँहरू चाहिँ 10वटा घरधुरी, 30वटा 35वटा घरधुरीहरूको पनि गाउँ छ। त्यसमा हामी सबै चाहिँ इन्टरनेटको पहुँचहरू पुऱ्याउन कोसिस गरिरहेका छौँ, र गर्दै पनि छौँ। र अर्को पार्ट भनेको चाहिँ यसमा हाम्रो चाहिँ कुनैमा पनि बाटोहरूको चाहिँ राम्रो चाहिँ फेसिलिटीहरू छैन। कर्णाली रिजन इभन सबै ठाउँमा चाहिँ 12 महिनाको रोडको फेसिलिटी छैन। बर्खामा हामी जान सक्दैनौँ। इभन सदरमुकाममा पनि जानलाई हामीलाई चाहिँ कहिले बाढीले, कहिले पहिरोले, अथवा चाहिँ कहिले चाहिँ पुल नभएको कारणले गर्दा रोकिनुपर्छ। र कति ठाउँमा चाहिँ हामीले मान्छेले बोकाउँछौँ, कति ठाउँमा चाहिँ घोडाबाट, खचोटबाट चाहिँ सामानहरू बोकाएर चाहिँ हामीले चाहिँ काम गरिरहेछौँ। अर्को च्यालेन्जेस भनेको कति ठाउँमा हामीले आफै पनि बाटो बनाएको छौँ, देख्न सक्नुहुन्छ यहाँ। र कति ठाउँमा चाहिँ हामी चाहिँ एयरलिफ्ट पनि गरेका छौँ। इभन तपाईँहरूलाई पनि थाहा छ होला, हुम्ला र डोल्पा चाहिँ तपाईँको रोड फेसिलिटीबाट नेसनल हाम्रो सरी राष्ट्रिय सडक सञ्जालमा जोडेको छैन। त्यसको लागि चाहिँ हामीले चाहिँ प्लेनबाट भए पनि सामान ढुवानी गरेका छौँ। र अर्को च्यालेन्जेस भनेको चाहिँ हाम्रो चाहिँ 4200 मिटर 4300 मिटरमा पनि हाम्रो टावरहरू छ, त्यसमा 6 महिनाबाट हिउँ पर्छ। र अर्को भनेको चाहिँ हामीसँग चाहिँ अर्को च्यालेन्जेस भनेको चाहिँ अल्टिट्युड सिकनेस, र त्यसमा चाहिँ लेक लाग्ने समस्याहरू पनि हाम्रो चाहिँ फेस गरेका छौँ। अर्को समस्या भनेको चाहिँ हाम्रो पुरै हिमाली ठाउँ पहाडी ठाउँ भएर लाइटनिङको चाहिँ धेरै नै समस्या छ, लोकल इस्युहरू पनि छ त्यति नै। अनि अर्को भनेको म्यान पावरको एक्सपर्ट म्यान पावर चाहिँ अनअभाइलेबिलिटी चाहिँ हाम्रो यहाँबाट काठमाडौँबाट अथवा चाहिँ कुनै पनि सहरबाट चाहिँ त्यहाँ जानलाई चाहिँ धेरैजना मान्छेहरू तयार हुनुहुन्न। हामीले त्यसको लागि चाहिँ त्यहीँको मान्छेलाई चाहिँ ट्रेन गराएर त्यहीँको मान्छेलाई चाहिँ एक्सपर्ट बनाएर चाहिँ हामीले चाहिँ काम गरिरहेछौँ। यो सानो फोटोहरू कति ठाउँमा चाहिँ हामी टेन्टबाट नै सर्भिस पनि टेम्पोरेरी चाहिँ टेन्टबाट पनि सर्भिसहरू अफ गरेर काम गरेका छौँ। यो चाहिँ क्लाइन्ट साइडको जिपिएस लोकेसनहरू यो हुम्ला जिल्लाको हो। यो सबै तपाईँहरूले देख्नु सक्नुहुन्छ, हिमाल पारी, हिमालको खोजमा, हिमालको टुक्रामा, पहाडको टुक्रामा चाहिँ साइडहरू छ। यो आफैमा च्यालेन्जिङ छ, पुग्नको च्यालेन्जिङ त छुट्टै छँदैछ, त्यसमा लिङ्क पुर्याउनुको च्यालेन्जेस त अर्को छँदैछ। यो हाम्रो कालीकोटको हो, यो हाम्रो मुगुको, सबै हिमालको काखमा, हिमालको वारी र पारी गाउँहरूमा यो जिपिएस कोअर्डिनेट गुगल अर्थबाट लिएको। अर्को यो ट्रङ्क लिङ्कमा यो प्रोजेक्ट अन्तर्गतको सबै ठाउँमा चाहिँ हामीले चाहिँ वायरलेस ट्रङ्क लिङ्क पुऱ्याएका छौँ। यसमा हाम्रो फाइबर अप लिङ्क भनेको चाहिँ सुर्खेत, सल्यान र तुलसीपुरबाट मात्रै गरेका छौँ। ट्रङ्क लिङ्कहरू हामीले चाहिँ सकेसम्म चाहिँ रिडन्डेन्ट छ सबै, ताकि एउटा साइड डाउन हुँदाखेरि चाहिँ होल सर्भिस इफेक्टेड नहोस्। र यो लिङ्कहरू चाहिँ हामीले 60-70 किलोमिटर इभन 80 किलोमिटरको लिङ्कहरू पनि गरेका छौँ। र त्यसपछि त्यो नेटवर्कबाट चाहिँ हामीले चाहिँ 10-15 किलोमिटरमा चाहिँ डिस्ट्रिब्युसन टावर राख्छौँ। त्यो डिस्ट्रिब्युसन टावरबाट चाहिँ हामीले चाहिँ क्लाइन्ट साइडलाई चाहिँ डिस्ट्रिब्युट गर्ने गरेका छौँ। यो सानो इक्जाम्पल नेटवर्क डायग्राम्सको। अर्को ट्रङ्क लिङ्क, हामीले चाहिँ यसको ट्रङ्क लिङ्कको लागि चाहिँ हामीले चाहिँ 20वटा चाहिँ 15 मिटर 20वटा चाहिँ 15 मिटरको टावर बनाएको छौँ। चारवटा चाहिँ हाम्रो चाहिँ 4000 मिटरभन्दा माथिको छ। सबै साइड चाहिँ हामीले चाहिँ सोलरबाट अपरेटर छ। त्यसमा चाहिँ 12वटा ब्याट्री र 12वटा सोलर प्यानल राखेका छौँ। र सबै ठाउँमा चाहिँ जेनेरेटर ब्याकअप छ। र अर्थिङ पनि हामीले चाहिँ केमिकल अर्थिङ गरेका छौँ सबै ठाउँमा। यो लिङ्क यो 61 किलोमिटरको लिङ्क हेर्न सक्नुहुन्छ। यसमा चाहिँ हामीले चाहिँ कति 350 MBPS को थ्रुपुट निकालेका छौँ। यो सबै हाम्रो चाहिँ केमिएमको डिभाइसहरू युज गरेर। यो चाहिँ 81 किलोमिटरको लिङ्क छ, यसमा 250 MBPS को चाहिँ थ्रुपुट आएको छ। र अर्को 70 किलोमिटरको 171 किलोमिटर लिङ्क छ, यसमा पनि हामीले चाहिँ 20-25 MBPS को थ्रुपुट निकालेर चाहिँ गरेका छौँ। यो यिनीहरू चाहिँ एक्जाम्पल मात्रै हो, यस्तो लिङ्कहरू चाहिँ हामीले चाहिँ धेरै नै गरेका छौँ। र यो टावरहरूको फोटो देख्न सक्नुहुन्छ, हाम्रो रिभर साइडमा भएको टावरहरू। यो टावर बनाउँदाखेरिको यो 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 चाहिँ भर्खरको फोटो हो, भर्खर काम गर्दा गर्दा हामी यो परेको साथीहरूले। अर्को चाहिँ डिस्ट्रिब्युसन टावर चाहिँ त्यसपछि हामीले चाहिँ यो प्रोजेक्टको लागि चाहिँ हामीले 100वटा भन्दा बढी डिस्ट्रिब्युसन टावरहरू बनाएका छौँ। यसमा चाहिँ 4वटा नम्बर अफ ब्याट्री र 4वटा नम्बर अफ सोलर प्यानल राखेका छौँ। ग्राउन्डिङ पनि केमिकल अर्थिङबाट सबै ठाउँमा चाहिँ हामीले गरेका छौँ। यो टावरहरू चाहिँ म्याक्सिमम् टावरहरू चाहिँ अनम्यान्ड साइडमा छ, गाउँ नभएको ठाउँमा, डाँडाको टुप्पामा। र यो डिस्ट्रिब्युसन टावरहरू हो। यो कुनै चाहिँ 50-60 फिटको टावरहरू पनि छ, कुनै चाहिँ हामी 30 फिटको मोनोपोल टावरमा गरेर राखेर डिस्ट्रिब्युट गरेका छौँ। अर्को यो क्लाइन्ट साइडमा हो। यो चाहिँ यो फोटो चाहिँ हुम्ला जिल्लाको हो। र यसमा चाहिँ हामीले चाहिँ सबै ठाउँमा चाहिँ राउटरहरू चाहिँ म्यानेजेबल राउटर राखेका छौँ, ताकि कुनै पनि समस्या आयो भने हामी रिमोटली नै म्यानेज गर्न सकौँ सानोतिनो समस्याको लागि भनेर। र यो छ यो क्लाइन्ट साइडमा, क्लाइन्ट आफै ट्युन गरिरहनु भएको छ एउटा फोटो। अर्को फोटो चाहिँ यो हाम्रो चाहिँ कहाँको भने राराको एयरपोर्ट, तालसा एयरपोर्ट, त्यो टर्मिनल हाउसमा पनि हामीले चाहिँ वाइफाई दिएर त्यो ठाउँमा पनि हामीले कनेक्सन गरेका छौँ। र अर्को कुरा हामीले चाहिँ 2075 साल वैशाख 1 गते चाहिँ प्रधानमन्त्री केपी शर्मा ओली प्रधानमन्त्रीले चाहिँ हाम्रो चाहिँ के देशवासीको नाममा चाहिँ राराबाट चाहिँ सम्बोधन गर्नुभएको थियो। त्यतिखेर हामीले प्रदेश सरकारको सहकार्यमा फ्री वाइफाई गरेका थियौँ र त्यसमा चाहिँ हामीले चाहिँ नेपाल टेलिभिजनलाई चाहिँ ब्यान्डविड्थ पनि प्रोभाइड गरेका थियौँ त्यो हाम्रो चाहिँ लाइभ टेलिकास्ट गर्नको लागि। त्यहाँ देख्न सक्नुहुन्छ केपी शर्मा ओलीद्वारा कर्णाली रारा पर्यटन वर्ष 2075 को उद्घाटन ब्यान्डविड्थ सपोर्टेड बाई होल्डिङ भनेर। यो बेलामा चाहिँ यो बेलाको हल्का स्मरण गर्न चाहन्छु कि त्यो बेलामा नेपाल टेलिभिजनको भिस्याट पनि ट्र्याक नहुँदाखेरि होल्डिङ कम्युनिकेसनको अथवा चाहिँ हामीले गरेको चाहिँ लिङ्कबाट चाहिँ नेपाल टेलिभिजन र रेडियो नेपालले चाहिँ लाइभ ब्रोडकास्ट गर्नुभएको थियो। यसमा त्यो बेलाको सानो भिडियो छ, अलिकति रन गराइदिनु। राराको लागि रिपिटरको फोटोहरू यिनीहरू। केही फोटोहरू मैले देखाएँ, यसबाट केही मेमोरीहरू ताजा पनि भएको छ। यसको लागि चाहिँ हामीले चाहिँ सबै हाम्रो चाहिँ नेटवर्कहरू चाहिँ सबै चाहिँ हाम्रो चाहिँ मोनिटरमा सबै चाहिँ हामी सेन्ट्रली मोनिटर गरेका छौँ। यसमा हाम्रो चाहिँ नाइजेस थ्रु चाहिँ सबै एपिज र स्विच ब्याकल्सहरू चाहिँ सबै चाहिँ हामीले नाइजेस थ्रु चाहिँ मोनिटर गरेका छौँ। यसमा चाहिँ हाम्रो सबै एसएमएस अलर्ट, अदर इमेल एसएमएस अलर्ट र कन्सर्न पर्सनलाई एसएमएस र इमेल चाहिँ इमेल आउँछ हाम्रो कुनै डाउन भयो र कुनै के भयो भने। अर्को चाहिँ सिएन मेस्ट्रोबाट चाहिँ हामीले क्लाइन्ट साइडमा चाहिँ सबै क्लाइन्ट साइड पनि हामीले चाहिँ मोनिटर गरेका छौँ। यसबाट चाहिँ हामीले चाहिँ कति ब्यान्डविड्थ क्लाइन्टले पाइरहेको छ र क्लाइन्टहरूको एसएसआइडी चेन्ज गर्न चाहेर र उनीहरूको कतिजना क्लाइन्ट रजिस्टर छ भन्ने चाहिँ हेर्न चाह्यो भने हामीले यहाँबाट हेर्न सक्छौँ। अर्को क्याक्टिभबाट चाहिँ हामीले चाहिँ ब्यान्डविड्थको क्लाइन्ट साइडको ब्यान्डविड्थहरू चाहिँ मोनिटर गरेका छौँ। सरी स्विच साइडको सबैबाट, ताकि हामी चाहिँ नहोस् के अरे त्यो कुनै ब्यान्डविड्थ चोक हुनुभन्दा पहिले नै अपडेट गर्न सकौँ। अर्को चाहिँ पावर मोनिटरिङ, सबै इच एन्ड एभ्री साइड चाहिँ हाम्रो चाहिँ पावर मोनिटरिङ छ। त्यसबाट चाहिँ हामीले ब्याट्री भोल्टेज, लोड करेन्ट र इनपुट करेन्ट चाहिँ मोनिटर गर्छौँ, ताकि कुनै पनि साइड चाहिँ पावरको कारणले गर्दाखेरि चाहिँ आउटेज नहोस्। अर्को यो एउटा दुईवटा फोटो मैले राखेको छु, यो चाहिँ रिकग्नेसन भनेर। यति नै खुसी हुनुहुन्छ कि क्लाइन्टहरू इभन फोनको पहुँच नभएको ठाउँमा, दूरसञ्चारको पहुँच नभएको ठाउँमा इन्टरनेट पुऱ्याएपछि उहाँहरू यति नै खुसी हुनुहुन्छ र उहाँहरू कति ठाउँमा सम्मानको कार्यक्रम राख्नुहुन्छ, कति ठाउँमा चाहिँ स्वागतको कार्यक्रम राख्नुहुन्छ। यो ठाउँमा यसको धेरै ठाउँको त नभनौँ, 2-4वटा साइडको साँची म पनि बसेको छु र यसमा चाहिँ यसमा हाम्रो मिडियाले पनि धेरै कभरेज गर्नुभएको छ उहाँहरूले। यो चाहिँ कान्तिपुरमा चाहिँ 1 महिना 1.5 महिना अगाडि कभरेज गर्नुभएको थियो, फ्री वाइफाई जडान तीव्र भनेर पछाडि ब्याकग्राउन्ड अफ तालको फोटो राखेर। अर्को लोकल न्युज पेपरहरूमा रुकुमको दुर्गम गाउँ सिस्ने गाउँपालिकामा पुग्यो होल्डिङको इन्टरनेट भन्ने किसिमकोहरू। अर्को क्लाइन्ट साइडको चाहिँ क्लाइन्ट साइडहरू फेसबुकमा पेजहरूबाट नि हामीलाई धन्यवाद दिइरहनु भएको छ। र यसमा चाहिँ यिनीहरू चाहिँ सानो प्रतिबिम्ब मात्रै हो, योभन्दा धेरै अरू चाहिँ कभर गर्न र धेरै कुराहरू अरू चाहिँ हाम्रो क्लाइन्ट साइडबाट धन्यवादहरू पनि दिइरहनु भएको छ। यो चाहिँ थवाङ रोल्पाको थवाङ गाउँपालिकाबाट चाहिँ गर्नुभएको छ। हस् त, धन्यवाद। मैले यति नै साइडमा राखेको छु।
भिडियो हेर्दा त मलाई त जाउँ जाउँ लाग्यो, हजुरहरूलाई पनि लाग्यो होला पक्कै पनि, होइन? यो पक्कै पनि आरटिडिएफको प्रोजेक्ट अन्तर्गत इनिसिएसन प्रोजेक्ट होला। यस्तै अरू क्षेत्रमा पनि यस्तै प्रोजेक्टहरू भएको होला। आगामी एनपिनगमा यस्तै प्रोजेक्ट स्टेटसहरू हामीले पाउँछौँ पक्कै पनि। यति भन्दै thank you for all the presenters for a wonderful presentation, and okay, fine. And also really appreciate for all the presenters for keeping in time. So that is what we are running short. So पक्कै पनि यो जुन प्रेजेन्टेसन छ यो this is one of the milestone which will help for the recent government of digital Nepal, which we are dreaming for. यस्तै अरू कामहरू पनि हुँदै गर्छ होला। त्यसरी नै हामी चाहिँ यो डिजिटल नेपालको लागि हामी अगाडि बढ्छौँ। यति भन्दै म यहाँ कन्क्लुड गर्न चाहन्छु। यो सँगै यसपछि हाम्रो टी ब्रेक हुन्छ। त्यो टी ब्रेक भन्दा अगाडि चाहिँ what we have, so is a token of love for the presenters. Yep. So I would like to invite Mr. Vinay Boraji, kindly come on stage for giving this. Okay. I would like to invite Mr. Anurag Bhatia. Hello, Mr. Anurag. Okay. The next presenters, Mr. Ramkrishna Dahal and Sitaram Khadka. I'd like to invite Mr. Kiran Devkota. Mr. Anurag, yeah, we'll distribute this later. So, okay. So we'll have, after this, like we'll have a 15 minutes tea break. After that, like we'll have the second technical operation sessions, which will start from, so I don't have time. So we'll start after 15 minutes. Thank you.